Welcome to Science Snippets Fun Facts and Trivia. Today, we bring you the International Day of Women and Girls in Science. Forgotten female scientists who changed the world. Chapter 1 Introduction: Why this day matters. Section 1 The significance of the International Day of Women and Girls in Science. Every year on February 11th, the world celebrates the International Day of Women and Girls in Science. But why is this day so important? And why was it established in the first place? In 2015, the United Nations declared February 11th as a global day of recognition to address a persistent issue: the underrepresentation of women in STEM fields. Despite their immense contributions throughout history, women have often been overlooked, excluded, or even erased from scientific achievements. This International Day serves as a reminder that gender equality in science is not just a matter of fairness. It's essential for the progress of humanity. Historically, many brilliant female scientists made groundbreaking discoveries, yet their names remain unknown to the general public. Why? Because for centuries, women were systematically denied access to formal education, laboratory space, funding, and recognition. Even when they made remarkable contributions, their work was often credited to male colleagues. Take a look at the statistics today. Women make up nearly 50% of the global population, yet they account for only 30% of researchers worldwide. The gender gap in STEM careers remains significant, especially in leadership positions, funding allocations, and academic recognition. Many young girls show a passion for science early on, yet societal expectations, lack of role models, and institutional biases often discourage them from pursuing careers in these fields. The consequences of this imbalance are profound. Science thrives on diversity. Every breakthrough, from medical advancements to space exploration, relies on the unique perspectives and creativity of those involved. If half the world's talent is underrepresented, we are limiting the potential of scientific innovation itself. How many cures, inventions, and discoveries have been delayed simply because the brilliant minds behind them were ignored or denied opportunities? The International Day of Women and Girls in Science is more than just a celebration. It's a call to action. It urges us to recognize past injustices, promote inclusivity, and inspire the next generation of female scientists. By breaking barriers and encouraging young girls to pursue STEM careers, we are not just empowering individuals, we are strengthening the future of science and society as a whole. So, as we explore the stories of forgotten female scientists who changed the world, remember their contributions may have been hidden, but their impact is undeniable. Let's begin. Section 2 The challenges women have faced in science throughout history. Science has always been a field of discovery, innovation, and progress. Yet, for centuries, women were systematically excluded from scientific institutions. Even when they made groundbreaking contributions, they were often denied credit, funding, and recognition. Why did this happen? And what challenges did female scientists have to overcome to make their mark in history? In the past, education itself was a privilege reserved for men. In ancient times, women were rarely allowed to study subjects like mathematics, astronomy, or medicine. Even during the Renaissance, when scientific knowledge flourished, women were largely expected to focus on domestic roles. Universities and scientific academies across Europe and other parts of the world explicitly barred women from enrolling. Despite these restrictions, some determined women still pursued knowledge. Many worked in secret, publishing their research under male pseudonyms. or contributing to male scientists' work without recognition. Others had to rely on family connections to gain access to scientific circles. For example, Caroline Herschel, a brilliant 18th-century astronomer, initially worked as an assistant to her brother, William Herschel. Though she made significant astronomical discoveries herself, she was often overshadowed by her brother's fame. Even in the 20th century, when more women gained access to higher education, institutional biases persisted. Women in STEM fields were frequently seen as less capable than their male counterparts. They struggled to receive funding for research, secure high-ranking positions, or have their work published in prestigious journals. Rosalind Franklin, whose X-ray diffraction images were crucial in discovering DNA's double helix structure, was largely ignored in favor of James Watson and Francis Crick. Had she been properly credited, she might have shared the Nobel Prize that Watson and Crick won in 1962. Beyond recognition, many female scientists had to fight against stereotypes. They were told that science was too difficult, too technical, or even unnatural for women. Some were forced to choose between their careers and societal expectations of marriage and motherhood. These cultural barriers made it even harder for women to break into science and be taken seriously. The effects of these historical challenges are still visible today. Women remain underrepresented in many STEM fields, particularly in physics, engineering, and computer science. While progress has been made, biases in hiring, promotion, and funding still persist. Women are also less likely to be invited as keynote speakers at scientific conferences and receive fewer patents than their male counterparts. So, what can we learn from history? The struggles of past female scientists show us that talent and intelligence are not limited by gender, opportunities are. By acknowledging these historical challenges, we can work toward a future where science is truly inclusive, allowing the best minds, regardless of gender, to thrive. Next, we'll explore another critical question. Why do women in science still struggle for recognition today? Section 3. Why do women still struggle for recognition in science? We've seen how history has systematically excluded women from science. But what about today? Why do female scientists still struggle for recognition, despite the progress we've made? While more women are entering STEM fields than ever before, they continue to face bias, underrepresentation, and a lack of recognition for their achievements. One of the biggest challenges is the gender gap in leadership and funding. Studies show that women in science receive less research funding than men, and are often assigned to lower status roles within research teams. Even when they produce groundbreaking work, they are less likely to be promoted to senior positions or awarded prestigious prizes. The Nobel Prize, for example, has been awarded to over 600 men in scientific fields, but fewer than 30 women have won. This isn't because women are less capable. It's because they haven't been given the same level of recognition. Another major issue is the bias in publishing and citations. Research has shown that papers written by female scientists receive fewer citations than those written by men. Additionally, women are often less likely to be invited as keynote speakers at major scientific conferences. This means their work gets less exposure, which directly impacts their career progression. In a field where reputation and visibility matter, this lack of recognition can slow down a woman's professional growth. The problem isn't just about numbers, it's also about perception. Women in science frequently face implicit biases that undermine their contributions. For example, studies have shown that when identical resumes are submitted for a job application, Those with male names are rated as more competent than those with female names. Women are also more likely to be questioned or interrupted during presentations and discussions. These subtle biases create a hostile work environment that makes it harder for women to advance. Moreover, there is still a cultural expectation that women should balance career and family responsibilities, often forcing them to make difficult choices. Many female scientists struggle with work-life balance, as they are expected to pursue research at the same intensity as their male colleagues, while also handling societal pressures related to family life. Maternity leave policies and lack of support in academia can make it even harder for women to remain in competitive scientific fields. So, how do we fix this? Change must come from both institutions and society. Universities and research institutions need to implement policies that promote gender equality, such as fair hiring practices, better funding distribution, and mentorship programs for women. At the same time, we must challenge outdated stereotypes about who belongs in science. Despite these obstacles, women in science continue to break barriers and push boundaries. Their contributions are changing the world, even if they don't always receive the recognition they deserve. That's why the International Day of Women and Girls in Science is so important. It reminds us of the progress we've made and the work that still needs to be done. In the next chapter, we'll explore some of the most overlooked female scientists in history, women whose incredible discoveries were forgotten, ignored, or credited to men. Chapter 2: More than Marie Curie overlooked female scientists. Section 1: Female scientists who changed the world but were forgotten. When people think of women in science, Marie Curie is often the first name that comes to mind. She was an extraordinary scientist, but she wasn't the only one. Throughout history, many brilliant female scientists made groundbreaking discoveries, yet their names remain largely unknown. Who were these women, and why have their contributions been forgotten? One of them was Lise Meitner, an Austrian physicist whose work led to the discovery of nuclear fission, the process that powers nuclear energy and atomic bombs. Despite her crucial contributions, the 1944 Nobel Prize in Physics went solely to her male colleague, Otto Hahn. Meitner was overlooked, even though she was the one who provided the theoretical explanation of how fission worked. Then there's Jocelyn Bell Burnell, an astrophysicist who discovered pulsars, rapidly spinning neutron stars that emit beams of radiation. Her discovery was revolutionary, yet her male advisor received the 1974 Nobel Prize, while she was completely excluded. Bell Burnell handled the injustice with grace, later using her prize money from other awards to fund scholarships for women in physics. Another forgotten figure is Qian-Shiung Wu, a Chinese-American physicist who played a key role in disproving the law of parity, a fundamental principle in physics. Her experiment proved that nature is not always symmetrical, which was a groundbreaking discovery in quantum mechanics. But when the Nobel Prize was awarded in 1957, it went to her two male colleagues. Wu's work reshaped physics, yet she never received the same level of recognition. So why were these women forgotten? The answer lies in systemic bias. Many scientific institutions, prize committees, and research communities historically viewed women as assistants rather than equals. Their work was often credited to male colleagues or dismissed as unimportant, even when it changed the course of science. By telling their stories, we can give these brilliant minds the recognition they deserve. Their contributions shaped nuclear energy, astrophysics, and quantum mechanics, fields that define our modern world. In the next section, we'll look at female scientists who deserved a Nobel Prize but never won. Section 2: The women who deserved a Nobel Prize but never won. The Nobel Prize is the highest honor in science, awarded to those who make groundbreaking discoveries. However, throughout history, many women who made revolutionary contributions were denied this recognition. Why? Bias, societal norms, and systemic exclusion played a major role. One of the most famous examples is Rosalind Franklin, whose work was crucial in discovering the structure of DNA. She used X-ray diffraction to capture the first clear image of DNA's double helix structure. Yet, when the Nobel Prize in Physiology or Medicine was awarded in 1962, only James Watson, Francis Crick, and Maurice Wilkins were honored. Franklin was ignored. Worse yet, Watson and Crick had used her data without her permission. Had she lived longer, she passed away at 37 from cancer. She might have finally received the recognition she deserved. Another overlooked figure is Lise Meitner, whose story we touched on earlier. She was the first person to explain the physics behind nuclear fission, the process that powers both nuclear reactors and atomic bombs. But instead of honoring her, the 1944 Nobel Prize went solely to her male colleague, Otto Hahn. Even Albert Einstein called her the German Marie Curie. Yet the Nobel Committee failed to recognize her contributions. Then there's Esther Lederberg, a microbiologist who made key discoveries in bacterial genetics. She developed a technique called replica plating, which allowed scientists to study antibiotic resistance. Her discovery was groundbreaking. Yet when the 1958 Nobel Prize in Physiology or Medicine was awarded for bacterial genetics, only her husband and 2 male colleagues received the prize. She was left out completely. So why were these women excluded? The Nobel Committee has long had a history of gender bias. Until recently, women were often seen as assistants, rather than primary researchers. Even when they made crucial contributions, they were pushed into the background. Today, efforts are being made to correct these injustices. More women are winning Nobel Prizes, and organizations are working to recognize forgotten female scientists. But these past cases remind us that brilliant minds were ignored, simply because they were women. In the next section, we'll explore how bias in society erased the contributions of many female scientists, and what we can do to change that. Section 3: How bias in society erased their contributions. Why were so many female scientists ignored, forgotten, or denied credit for their work? The answer lies in systemic bias, cultural expectations, and institutional barriers that have persisted for centuries. Even as women broke into the world of science, their contributions were often erased by gender discrimination. One common way this happened was through the Matilda effect, a term used to describe how women's scientific achievements are often credited to their male colleagues. This phenomenon has occurred repeatedly throughout history. We've already seen how Rosalind Franklin's DNA research was taken by Watson and Crick, and how Lise Meitner's nuclear fission discovery was attributed to Otto Hahn. But these are just a few examples. In many cases, female scientists were forced to work behind the scenes, publishing research under male colleagues' names. Jocelyn Bell Burnell, who discovered pulsars, was only recognized decades later, after her male supervisor received the Nobel Prize for her work. Similarly, Chien-Shiung Wu, who made groundbreaking discoveries in physics, was left out when her male colleagues won the Nobel Prize. Another major factor was societal expectations. For centuries, women were expected to focus on family life, rather than scientific careers. Even when they pursued science, they faced constant pressure to step aside for male counterparts. Many women worked as unpaid assistants, or had to abandon their research due to marriage and motherhood. Bias also affected funding and opportunities. Universities and research institutions were historically male-dominated, making it difficult for women to secure lab space, financial support, or leadership positions. Even today, studies show that female scientists receive less funding than men, and are underrepresented in prestigious academic positions. The impact of these barriers is clear. Women have contributed enormously to science, yet history has systematically erased their names. Today, efforts are being made to recognize their work, but there is still progress to be made. In the next chapter, we'll explore one of the earliest female pioneers in computing, Ada Lovelace, the woman who predicted modern computers long before they existed. Chapter 3: Ada Lovelace, the mother of computing and her vision of the future. Section 1: Who was Ada Lovelace? Before computers existed, before the world even imagined artificial intelligence, there was a woman who saw the future of technology with incredible clarity: Ada Lovelace. Born in 1815, Ada was the daughter of the famous poet Lord Byron. But instead of following in her father's literary footsteps, she chose a different path: mathematics and science. During the 19th century, women were rarely encouraged to study advanced mathematics. But Ada was different. Her mother, fearing that she would inherit her father's reckless creativity, pushed her toward logic, numbers, and analytical thinking. This unconventional education shaped Ada into a brilliant thinker, allowing her to break barriers in a male-dominated scientific world. Her life changed when she met Charles Babbage, a British mathematician and inventor. Babbage was working on a machine called the analytical engine, an early mechanical computer that could perform calculations. Most people saw it as a complex calculator, but Ada saw something far more revolutionary. She realized that this machine could go beyond numbers and process information like a modern computer. In 1843, Ada translated an article about the analytical engine from French to English, but she didn't stop there. She added her own extensive notes, which ended up being 3 times longer than the original paper. In these notes, she described a set of instructions for the machine that is now considered the first computer program in history. She also had a profound insight. Computers could do more than just calculate numbers. She predicted that a machine like the analytical engine could eventually create music, compose art, and even make decisions, concepts that define modern computing today. This vision was over a century ahead of its time. Despite her brilliance, Ada's work was largely forgotten after her death at the young age of 36. It wasn't until the 20th century, when computers became a reality, that her ideas were recognized. Today, she is celebrated as the world's first computer programmer, and her legacy continues to inspire generations of women in STEM. But how exactly did Ada Lovelace predict modern computing? In the next section, we'll explore how her revolutionary ideas laid the foundation for today's technology. Section 2: How she predicted modern computing and artificial intelligence. When Ada Lovelace studied Charles Babbage's analytical engine, she saw something that no one else did: a machine that could go beyond simple calculations. At a time when most people viewed machines as nothing more than tools for arithmetic, Ada envisioned something far greater. a universal computing device capable of processing symbols, logic, and even creativity. In her famous 1843 notes, she described how the analytical engine could follow a sequence of instructions, making it the first conceptual example of a programmable computer. This idea was groundbreaking because it suggested that machines could be programmed to perform any logical task, much like modern computers. But Ada didn't stop there. She took her vision even further by predicting something that today is a core concept of artificial intelligence. Computers could be used for creative purposes. She suggested that a machine could process not just numbers but also musical compositions, artistic patterns, and language-based information. This was an extraordinary prediction, considering that mechanical computers wouldn't even exist for another 100 years. Her ideas directly inspired the work of Alan Turing, the father of modern computing. Turing, who developed the foundation for artificial intelligence, referenced Ada Lovelace's work when discussing the potential of thinking machines. However, Ada herself remained skeptical about the possibility of true AI. She believed that machines could follow complex instructions, but would never be capable of original thought. This has led to a long-standing debate in computer science, often called the Lovelace question. Can a machine ever truly be creative? Unfortunately, Ada Lovelace's work was not recognized in her lifetime. It wasn't until the 20th century, when computers became a reality, that scientists rediscovered her notes and realized their significance. Today, she is considered the first computer programmer and a visionary thinker who saw the future of technology long before it existed. But why was Ada Lovelace's work ignored for so long? In the next section, we'll explore why her contributions were nearly lost to history, and how she finally gained recognition. Section 3: Why her work was ignored for so long. Ada Lovelace's ideas were revolutionary, yet for more than a century, her contributions remained almost entirely forgotten. Today, she is celebrated as the first computer programmer, but during her lifetime and long after her death, her work was largely dismissed. Why was such a brilliant mind overlooked for so long? One of the biggest reasons was gender bias. Ada lived in the 19th century, a time when women were discouraged from engaging in science and mathematics. Despite her extraordinary intellect, she was often seen as an exceptional woman, rather than an equal scientist. Even though she worked closely with Charles Babbage, many of their contemporaries assumed she was merely an assistant rather than an independent thinker. Her deep understanding of programming concepts was ignored, simply because it was difficult to believe that a woman could have conceived such advanced ideas. Another major factor was that her ideas were far ahead of their time. The analytical engine, which she described in her famous 1843 notes, was never actually built during her lifetime. Without a physical machine to demonstrate its capabilities, her theories remained abstract and speculative. The world wasn't ready for the kind of computing power she had envisioned, and as a result, her notes were largely forgotten. Additionally, historical records of scientific contributions have traditionally favored men. Many influential scientific papers and inventions were credited to men, while women's contributions were minimized or erased. Ada's work was no exception. Her notes remained buried in archives for decades. While Babbage was widely remembered as the father of the computer, it wasn't until the 20th century, when actual computers were being developed, that scientists and historians rediscovered her work. In the 1950s, researchers studying the history of computing found that Ada's notes contained the first published example of an algorithm designed for a machine, in other words, the first computer program. Her insights into how computers could process symbols and logic, rather than just numbers, were also recognized as an early foundation of modern computing. By the 1970s, Ada Lovelace was finally getting the recognition she deserved. In 1980, the U.S. Department of Defense named a new computer programming language Ada in her honor, ensuring that her name would be remembered in the world of technology. Today, she is widely regarded as a pioneer, not just in computer science, but in the idea that machines could one day become powerful tools for creativity, artificial intelligence, and beyond. Ada Lovelace's story is a reminder that women in science have often been ignored, not because of a lack of talent, but because of societal barriers and historical biases. But as her legacy proves, the truth always comes to light. In the next chapter, we'll explore another group of brilliant female pioneers, women who helped us understand the universe. Chapter 4: Women who helped us understand the universe. Section 1: Henrietta Leavitt and her role in measuring the universe. The universe is vast, mysterious, and constantly expanding. But how did we measure its size? How do we know the distance to stars and galaxies? One woman's discovery changed everything. Henrietta Leavitt. Born in 1868, Henrietta was a talented astronomer who worked at Harvard College Observatory in the early 20th century. At the time, women in astronomy were not given the same status as men. Instead of leading research, they were often hired as computers, a term used for women who performed complex calculations by hand. They were paid little, received no academic recognition, and were expected to work behind the scenes, while male astronomers took credit for discoveries. Despite these barriers, Leavitt made one of the most important discoveries in astronomy. While studying Cepheid variable stars, a type of star that pulses in brightness, she noticed a pattern. The brighter the Cepheid, the longer its cycle of brightening and dimming. This meant that Cepheids could be used as cosmic yardsticks to measure distances in space. Her discovery, known as the Leavitt Law, laid the foundation for modern astronomy. Using this method, astronomers could calculate the distances to faraway galaxies, ultimately proving that the universe was much larger than previously thought. Her work directly enabled Edwin Hubble to later discover that the universe is expanding, one of the most important breakthroughs in cosmology. However, Henrietta Leavitt never received the credit she deserved. She worked tirelessly despite suffering from illness for much of her life. Yet her discoveries were largely ignored during her lifetime. In fact, she was nominated for a Nobel Prize in Physics in 1925. But she had already passed away 4 years earlier. Since Nobel Prizes are not awarded posthumously, she was never officially honored. Her contributions, however, have stood the test of time. Today, her discovery remains one of the most crucial tools in astrophysics, allowing scientists to map the cosmos and understand the scale of the universe. Henrietta Leavitt's story is a reminder that brilliant women have shaped our understanding of space, even when history tried to forget them. In the next section, we'll explore another female pioneer, Vera Rubin, the woman who uncovered the hidden force of dark matter. Section 2: Vera Rubin and the hidden truth of dark matter. When we look up at the night sky, we see countless stars, planets, and galaxies. But what if I told you that most of the universe is invisible? The discovery of dark matter, an unseen force that makes up most of the cosmos, was one of the biggest breakthroughs in astrophysics, and the scientist who proved its existence was Vera Rubin. Born in 1928, Vera was fascinated by the stars from a young age. But as a woman in astronomy, she faced constant challenges. In the 1950s and 60s, many universities did not accept women into their astronomy programs, and prestigious observatories often denied them access to research facilities. However, Vera refused to let these obstacles stop her. She pursued her passion and became one of the most influential astronomers of the 20th century. Her most groundbreaking work came in the 1970s, when she studied the rotation of galaxies. According to the laws of physics, stars on the outer edges of a galaxy should move more slowly than those near the center, much like planets orbiting the sun. But Vera found something shocking. The outer stars were moving just as fast as the inner ones. This defied everything scientists expected. Her findings provided the strongest evidence yet for the existence of dark matter, an invisible substance that makes up about 85% of the universe and holds galaxies together with its gravitational pull. This discovery changed our understanding of the cosmos, leading to new theories about how the universe formed and evolved. Despite her monumental contributions, Vera Rubin was never awarded a Nobel Prize, even though many believed she deserved one. However, her impact on science is undeniable. Today, her research remains a cornerstone of modern astrophysics, and she is regarded as a pioneer who reshaped our understanding of the universe. Vera Rubin's story is a testament to the power of perseverance. Even when faced with barriers, she pushed forward and made one of the most important discoveries in modern astronomy. In the next section, we'll explore other female pioneers in astronomy and their contributions to space science. Section 3: Other female pioneers in astronomy. Henrietta Leavitt and Vera Rubin made groundbreaking discoveries, but they weren't alone. Many other brilliant women in astronomy made key contributions to our understanding of the universe, yet their names remain far less known than their male counterparts. One of these pioneers was Cecilia Payne-Gaposchkin, who, in 1925, made a discovery that changed our understanding of the stars. Before her research, scientists believed that the Sun and other stars were composed mostly of the same elements as Earth, heavy elements like iron and carbon. But Payne's work showed that stars were primarily made of hydrogen and helium, forming the basis of what we now call stellar composition theory. This was a revolutionary finding, but at the time, male scientists dismissed her conclusion, and a fellow astronomer even took credit for her work. It took decades for her discovery to be fully acknowledged. Another forgotten name is Nancy Grace Roman, often called the mother of the Hubble Space Telescope. In the 1960s, she became one of the first women to hold an executive position at NASA. She played a critical role in developing space telescopes, which would later revolutionize astronomy. Without her leadership, the Hubble Space Telescope, one of the most important astronomical tools ever built, might never have become a reality. Then there's Margaret Burbidge, who, in the 1950s, helped prove that the elements that make up planets, life, and even our bodies were formed inside stars. Her research showed that heavy elements like carbon, oxygen, and iron were created through nuclear fusion in stars, and then spread through space when stars exploded. This concept, known as stellar nucleosynthesis, is one of the foundations of modern astrophysics. Despite her contributions, Burbidge was often denied research positions and was even rejected from using a major telescope, simply because she was a woman. What these women had in common was brilliance, determination, and the ability to push forward despite obstacles. Their discoveries reshaped astronomy, yet they were often denied credit, funding, and professional opportunities. Today, things are changing, but the legacy of these women reminds us that science has always been shaped by those who dared to challenge the status quo. In the next chapter, we'll shift from astronomy to one of the greatest mysteries of biology, the discovery of DNA's structure and the woman whose contributions were overshadowed by her male colleagues Rosalind Franklin. Chapter 5: The Untold Story of Rosalind Franklin and DNA's Discovery. Section 1: The True Contribution of Rosalind Franklin to DNA Research. Every living organism on Earth is built from DNA, the molecule that carries genetic instructions. The discovery of DNA's double helix structure is one of the most important breakthroughs in science. But the woman behind this discovery, Rosalind Franklin, was largely ignored during her lifetime. Born in 1920 in London, Rosalind Franklin was a brilliant chemist and expert in X-ray crystallography, a technique used to study the structure of molecules. In the early 1950s, she worked at King's College London, where she focused on analyzing DNA fibers. Using X-ray diffraction, she captured an image known as Photo 51, the first clear evidence of DNA's double helix structure. This image was the key to understanding how genetic information is stored and passed from one generation to the next. However, Franklin faced constant challenges as a female scientist. The academic environment at King's College was highly exclusionary, often treated as outsiders, and Franklin was no exception. Her colleague, Maurice Wilkins, frequently undermined her work and failed to collaborate with her. The real injustice happened when her crucial Photo 51 was secretly shown to James Watson and Francis Crick without her permission. Watson and Crick, working at the University of Cambridge, were trying to determine the structure of DNA but lacked solid experimental data. When they saw Franklin's X-ray image, they immediately realized that DNA had a double helix shape. Using her data, they completed their model of DNA's structure, without informing or crediting Franklin. In 1953, Watson and Crick published their famous paper on DNA in Nature, acknowledging Franklin's research only in passing. But by then, the damage was done. Her data had been used without her consent, and she was never invited to collaborate on the final breakthrough. Despite this betrayal, Franklin continued her research on viruses and made significant discoveries in structural biology. Tragically, she passed away in 1958 at the young age of 37 from ovarian cancer. 4 years later, in 1962, Watson, Crick, and Wilkins were awarded the Nobel Prize in Physiology or Medicine for the discovery of DNA's structure, but Franklin, who had provided the key evidence, was not included. The Nobel Prize is not awarded posthumously, meaning she never had the chance to receive the recognition she truly deserved. Her story is a powerful reminder of how brilliant female scientists have been overlooked throughout history. But in recent years, Franklin's contributions have finally gained the recognition they deserve, and today she is rightly celebrated as a pioneer in DNA research. In the next section, we'll dive deeper into how her data was taken and why her contributions were downplayed for so long. Section 2: How her work was taken by Watson and Crick. The discovery of DNA's double helix structure is often credited to James Watson and Francis Crick. But what many people don't realize is that their breakthrough would have been impossible without Rosalind Franklin's work. So how did her crucial data end up in their hands? And why was she denied recognition? In the early 1950s, Franklin was working at King's College London, using X-ray crystallography to study the structure of DNA. She was meticulous and methodical, producing the most detailed images of DNA ever seen at the time. One of these images, Photo 51, provided definitive proof that DNA had a double helix structure. However, Franklin faced constant obstacles in her work environment. Her colleague, Maurice Wilkins, who was also studying DNA, saw her as competition rather than a collaborator. Their professional relationship was tense, and Wilkins often dismissed her contributions. This tension played a critical role in what happened next. Without Franklin's knowledge or consent, Wilkins showed Photo 51 to James Watson in early 1953. When Watson saw the image, he immediately recognized its significance. This was the missing piece he and Crick had been searching for. Using Franklin's data, they built their final DNA model, confirming that it was a double helix. The most shocking part? Franklin was never informed that her data had been shared. She had no idea that Watson and Crick had used her X-ray images to complete their discovery. By the time they published their famous paper in Nature in April 1953, Franklin's contribution was only briefly mentioned, far from the full credit she deserved. To make matters worse, Watson later spoke dismissively about Franklin. In his book, The Double Helix, he portrayed her as difficult and stubborn, reinforcing stereotypes about women in science. It wasn't until decades later that historians and scientists reevaluated her role and acknowledged that her data was essential to the discovery. Even after her death, her contributions continued to be downplayed. In 1962, Watson, Crick, and Wilkins received the Nobel Prize in Physiology or Medicine for their work on DNA. Since Franklin had passed away in 1958, she was no longer eligible for the prize. But many believe that she should have been recognized alongside them. Today, Rosalind Franklin's name is finally receiving the respect it deserves. Her work laid the foundation for modern genetics, biotechnology, and medical research, impacting everything from forensic science to gene therapy. But this raises an important question. What would science look like if Franklin had been properly credited and given the same opportunities as her male colleagues? We'll explore this in the next section. Section 3: What would science look like if she had been recognized? History is full of what-if moments, and Rosalind Franklin's story is one of them. What if she had been properly credited for her work? What if she had lived long enough to receive the recognition she deserved? How might the world of science have been different if women like Franklin were given equal opportunities from the start? First, if Franklin had been recognized as a co-discoverer of DNA's structure, it could have challenged the gender bias in science earlier. The 1950s were a time when women were often dismissed in scientific fields, and Franklin's exclusion from the Nobel Prize reinforced the idea that women's contributions were secondary. Had she been awarded the prize, it might have encouraged more women to pursue STEM careers decades earlier. Second, her presence in the field of molecular biology could have led to faster advancements in genetics and medicine. After her work on DNA, Franklin made significant contributions to virus research. If she had lived longer, she might have played a key role in early genetic engineering, cancer research, or even the development of treatments based on DNA sequencing. Another major impact could have been in the way scientific credit and collaboration were handled. Franklin's story is often cited as an example of how women's contributions have been overlooked in favor of their male colleagues. If she had been properly recognized, It might have changed how institutions acknowledge contributions in collaborative research, ensuring that credit is given fairly. Finally, her legacy serves as a lesson in ethics and integrity in science. The way her data was used without her knowledge is a reminder of why transparency and fairness in research are essential. Today, many scientists and historians use Franklin's case as an example of how science should be more inclusive and just. Although she never saw the recognition she deserved in her lifetime, her contributions live on. Today, Franklin's name is celebrated in genetics and numerous research centers. Scholarships and institutions are named in her honor. Her work laid the foundation for modern DNA research, which continues to impact medicine, forensics, and biotechnology. Rosalind Franklin's story is a powerful reminder that science advances not just because of discoveries, but because of the people behind them. And when we fail to recognize those people, we lose something valuable, not just their names, but the progress they could have made. In the next chapter, we'll shift our focus to the modern era, how today's female scientists are shaping the future of STEM and breaking barriers that once seemed impossible to overcome. Chapter 6: Modern Female Scientists Shaping the Future. Section 1: Women Leading the Fields of AI, Climate Science, and Space Exploration. Science is no longer a world dominated by men. Today, women are leading groundbreaking research in fields that will define the future: artificial intelligence, climate science, and space exploration. These women are not just continuing the legacy of pioneers like Ada Lovelace and Rosalind Franklin. They are shaping the world of tomorrow. One of the most influential women in artificial intelligence AI today is Fei Li, a professor at Stanford University. She played a major role in developing computer vision, the technology that allows machines to see and recognize objects. Her work has transformed everything from self-driving cars to medical imaging. She is also an advocate for ethical AI, emphasizing the need for fairness and diversity in machine learning. In the field of climate science, Katherine Hayhoe is making a huge impact. A leading atmospheric scientist, she has dedicated her career to studying climate change and its effects on human societies. Her research has influenced government policies and international climate agreements, helping the world understand the urgent need for action. She also works to bridge the gap between science and the public, ensuring that climate change is not just a scientific issue, but a conversation that involves everyone. When it comes to space exploration, Katie Bouman became famous in 2019 for leading the development of an algorithm that helped create the first ever image of a black hole. This was a historic moment in astronomy, proving that black holes exist as predicted by Einstein's theory of relativity. Her contribution showed the world that women are at the forefront of some of the biggest discoveries in modern science. These women are proof that barriers are being broken. Yet, challenges remain. Women in STEM still face biases, funding gaps, and underrepresentation in leadership roles. But with more female role models like Fei Li, Katherine Hayhoe, and Katie Bouman, the future of science is becoming more inclusive and diverse than ever before. In the next section, we'll explore how the role of women in science is evolving and what progress still needs to be made. Section 2: How the role of women in science is evolving. Over the past century, the role of women in science has changed dramatically. Once excluded from universities and research institutions, women now lead groundbreaking discoveries, direct space missions, and shape the future of technology. But while progress has been made, there is still a long way to go. One of the biggest changes is the increasing number of women in STEM fields. Today, more women than ever are earning degrees in science, technology, engineering, and mathematics. In medicine and biology, women now make up nearly 50% of researchers. However, in fields like physics, engineering, and computer science, women are still significantly underrepresented. Another major shift is the rise of female leadership in science. Jennifer Doudna, for example, co-developed CRISPR gene editing technology, which is revolutionizing medicine. France A. Cordova, an astrophysicist, became the director of the National Science Foundation, NSF, overseeing billions of dollars in research funding. Women are now leading major institutions, yet they still face challenges in reaching top positions. One key issue is funding disparities. Studies show that female scientists receive less research funding than their male counterparts, making it harder for them to conduct independent research. Additionally, women in science are often less likely to be invited as keynote speakers at conferences, which limits their visibility and influence. There is also the challenge of work-life balance. Science is a demanding field, and many women face pressure to choose between their careers and family responsibilities. While some institutions have improved policies for parental leave and childcare, many women still struggle to balance both worlds. Despite these challenges, change is happening. More programs and organizations are working to support women in STEM, offering scholarships, mentorships, and leadership training. Social movements advocating for gender equality in science are gaining momentum, encouraging a new generation of female scientists to step forward. The evolution of women's roles in science proves one thing: when given opportunities, women make groundbreaking contributions. But there is still work to be done to create a truly equal playing field. In the next section, we'll look at how today's female scientists are inspiring the next generation of women in STEM. Section 3: Inspiring the next generation of female scientists. Science has always been driven by curiosity, innovation, and discovery. But for centuries, many brilliant female minds were excluded from the field. Today, as more women break barriers in STEM, a new challenge emerges. How do we inspire the next generation of female scientists? One of the most powerful ways to encourage young girls to pursue science is through representation and role models. Studies show that when girls see successful female scientists, they are more likely to imagine themselves in those roles. Initiatives like Girls Who Code, NASA's mentorship programs, and STEM outreach in schools are helping to bridge the gap by connecting young women with leaders in science and technology. Education also plays a crucial role. Research has found that gender biases in science start early, even in elementary school. Many girls believe that math and science are boys' subjects. To change this, we need inclusive STEM education that encourages curiosity in all students, regardless of gender. Programs that promote hands-on science experiences, coding workshops, and robotics competitions are helping young girls build confidence in their scientific abilities. But inspiration goes beyond just seeing role models. It also requires systemic change. Universities and research institutions must continue working to close the gender gap in STEM, offering equal opportunities, mentorship, and career support. Policies that address issues like gender bias in hiring, funding, disparities, and work-life balance can create a more inclusive environment for women in science. The future of STEM depends on diversity and inclusion. When women and girls are empowered to pursue science, We unlock the full potential of human innovation. By fostering an environment where everyone has the opportunity to contribute, we ensure that the next generation of discoveries will be driven by the brightest minds, regardless of gender. As we celebrate the achievements of women in science, we must also look forward and ask what more can we do to support future female scientists. Because the discoveries of tomorrow start with the opportunities we create today. In the final chapter, we'll discuss what still needs to be done to bridge the gender gap in science, and how we can all contribute to a more equal future. Chapter 7 Conclusion: How can we bridge the gender gap in science? Section 1 Steps needed to create more opportunities for women in STEM. The contributions of women in science have shaped our world, from unlocking the mysteries of DNA to exploring the vastness of space. Yet, the gender gap in STEM still exists, limiting opportunities for many brilliant female minds. So, what can be done to bridge this gap and create a future where talent, not gender, determines success in science? One crucial step is improving access to STEM education. Many young girls lose interest in science at an early age, often due to a lack of encouragement or societal stereotypes. Schools and educators must actively promote STEM subjects to girls, providing hands-on learning experiences, mentorship, and role models to show that science is for everyone. Another key factor is ensuring equal opportunities in research and funding. Studies show that women receive less research funding than men, and are underrepresented in leadership positions. To fix this, scientific institutions and funding agencies must implement fair policies that eliminate gender bias, ensuring that women have equal access to grants, resources, and career advancement. Workplace culture also plays a major role. Many female scientists face challenges such as discrimination, unequal pay, and lack of support for work-life balance. Companies and research organizations must create inclusive environments, offering mentorship programs, leadership training, and flexible policies that support women in both their professional and personal lives. Representation in media and public recognition is another powerful tool. The more we highlight the achievements of female scientists, the more young girls will be inspired to follow in their footsteps. Recognizing women's contributions through awards, documentaries, and public outreach helps reshape the perception of who belongs in science. Finally, allies play a critical role. Gender equality in science isn't just a women's issue, it's a global issue. Men, institutions, and policymakers must actively support and advocate for inclusion in STEM, ensuring that future generations have a truly level playing field. Progress is being made, but there is still work to do. By taking these steps, we can create a world where science benefits from the full range of human talent, unlocking discoveries that will shape the future. In the next section, we'll explore why the International Day of Women and Girls in Science matters, and how it continues to drive change. Section 2: Why the International Day of Women and Girls in Science matters. Every year on February 11th, the world celebrates the International Day of Women and Girls in Science. But why is this day so important? Is one day enough to change a deeply rooted gender gap in STEM? While a single day may not fix everything, it plays a crucial role in raising awareness, inspiring young minds, and pushing for real change. One of the biggest impacts of this day is visibility. Throughout history, female scientists have often been overlooked, erased, or credited under male colleagues' names. By dedicating a day to recognizing their contributions, we are rewriting history and ensuring that their achievements are remembered. This not only honors past pioneers, but also encourages young girls to see themselves as future scientists, engineers, and innovators. Another key aspect is education and outreach. Schools, universities, and organizations around the world use this day to host science fairs, workshops, and mentorship programs aimed at empowering girls in STEM. These efforts help break down stereotypes and show that science is not just a field for men. It is a field for anyone with curiosity and determination. The day also serves as a global call to action. It reminds governments, institutions, and businesses that more work needs to be done to close the gender gap in science. Equal pay, fair hiring practices, and funding opportunities for female researchers are not just ethical choices. They are necessary for scientific progress. When women are excluded, we lose brilliant ideas, perspectives, and discoveries that could benefit all of humanity. Finally, this day is about celebrating progress. More women than ever are entering STEM fields, leading groundbreaking research, and taking on leadership roles. However, the fight for gender equality in science is far from over. The International Day of Women and Girls in Science is not just a celebration. It is a reminder of the challenges that still exist and the work that lies ahead. In the final section, we'll discuss what each of us can do to support women in science and ensure a more equal future for all. Section 3: What can we do to support women in science? The journey toward gender equality in science is far from over. But the question is, what can we do to help? Change doesn't happen overnight, but every action, big or small, matters. Whether you're a student, educator, scientist, or simply someone who cares about the future of STEM, you can play a role in supporting women in science. One of the simplest yet most powerful things we can do is amplify the voices of female scientists. Follow and support women in STEM on social media. Share their work, and encourage young girls to learn about female pioneers in science. When we highlight their contributions, we help reshape the narrative that science is for everyone. For educators and mentors, the key is early encouragement. Studies show that many young girls lose interest in STEM because they don't see enough role models or feel that science isn't for them. Schools and teachers can help by introducing diverse scientific role models, organizing hands-on STEM activities, and creating inclusive learning environments where everyone feels welcome. Companies and institutions must also take responsibility. Creating equal opportunities means ensuring that women receive fair funding, equal pay, and leadership roles in STEM fields. Research shows that diversity leads to more innovative and effective scientific discoveries, which benefits not just women, but all of society. On a personal level, we can all challenge stereotypes. The next time someone assumes that men are naturally better at math, or that engineering is a male field, speak up. Challenge outdated beliefs and encourage those around you to do the same. Changing minds leads to changing systems. Finally, governments and policymakers need to continue supporting initiatives that promote women in STEM. Scholarships, mentorship programs, and policies that help women balance careers and family life are essential to keeping more women in science. The future of STEM depends on diversity, inclusion, and equal opportunity. When women are given the same chances as men, the entire world benefits, from groundbreaking medical advancements to revolutionary space exploration. So the next time you think about the future of science, ask yourself, how can I help create a world where talent, not gender, defines success? The answer starts with awareness, action, and a commitment to making science a place for everyone. Final words. Women in science have faced centuries of obstacles, yet they have persisted. innovated, and changed the world. From Ada Lovelace's vision of computing to Rosalind Franklin's contributions to DNA, and Vera Rubin's discovery of dark matter, their impact is undeniable. But their stories also remind us that recognition and opportunities matter. The International Day of Women and Girls in Science is a time to celebrate progress, but also to acknowledge the work that still needs to be done. The future of science is diverse, inclusive, and filled with untapped potential. Let's work together to ensure that the next generation of female scientists doesn't have to fight for recognition, they simply receive it. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.